identity, and we're all going to talk about how to implement self-sovereign identity within Cosmos SDK. So basically, this workshop will take turns, and we'll have like a contribution from Egidio Casati, who has like previously basically recorded this this presentation. It's around like 50 minutes where he will basically explain on a very high level what is the self-sovereign identity and how we have implemented the self-sovereign identity within the Cosmos SDK at commercial network. So I will just like kind of like piece things together. So my name is Enrico Taline, and I am the CEO of Commercial Network. Okay? And basically after that, after Egidio presentation, we will stop with and we'll start like doing some coding with another Enrico, which is Enrico Pasquali. Hi, Enrico.
Yes. Hi.
And then we will like go and see how these apply in the real world, and we will show you a little bit about our stack and our basically free open source tools about developing self-sovereign identity Flutter app. Okay, of course Enrico will speak more about Flutter, but basically Flutter is this amazing, awesome framework from Google, where basically with a single code base you can develop and deploy basically any application for iOS, for Android, for Mac, for Windows, for Linux in one single code. So he will like really try to demonstrate how we can apply that, because of course the blockchain is super cool, but we need also to have like this blockchain technology applied to the people. And so the user usually have these 5 kind of devices, either like a mobile phone, iOS and Android, either like a Mac, a PC, a Windows, and a Linux. So these are like the 5 things that works right now with the Flutter. So in a nutshell, today we're really going to spend a couple hours about self-sovereign identity, and that's it. So I will just like start getting Egidio to talk about it, and then like in around 50 minutes I'll pick it up again, and we'll talk. We'll have like a very practical, let's say, presentation with Enrico about Flutter. Thank you very much. And let's give the word to Egidio.
With the responsibility of designing the infrastructure in order to be compliant to regulation, particularly to UIDAs. But I will explain more in detail later in the presentation. So the aim of this presentation is to introduce you to the basic concept of self-sovereign identity and to have a look on how we implemented this concept in the commercial network blockchain. So first of all, just 1 minute to present myself. I'm sorry to not being able to make it in live, but I had unforeseen events for this afternoon. So I decided with the an R&D manager. So I've been working for several certification authorities all across Europe with many projects in digital transformation field. After having the chance to look down deep in detail in the Bitcoin protocol around 2015, I decided to leave that market and open my startups. So actually, at the moment, I'm the founder of and CEO of NYM, which is a startup based in Milan, working on enterprise class project using decentralized technology. And I'm also co-founder of Black Art Network, which is a company based in Hong Kong, working in the NFT space and digital collectible space. If you are familiar with that space, you may have heard in the last few weeks about the project called Rapid CryptoPunks, and we are the company behind that project. Of course, I started 2 years ago working with Enrico to the commercial network blockchain, which is an enterprise business-to-business blockchain, which aims to mix an important concept, so to leverage the decentralized technology to design ideas for a greener, smarter, resilient, yet regulation-wise business. This is the mission of NYM, which totally overlap to the mission of commercial network, particularly to the extent of working accordingly to the European framework called UIDAS. I don't know if you are familiar with UIDAS framework. UIDAS has been introduced in the European community in 2016. And it's a regulation that allows to have a single digital market all across the continent. In the map that you see, there are some numbers. These are the numbers of qualified trust service provider. As you may see, Italy, our nation, our country, hosts the majority of them. These are numbers of few months ago, so may have changed. UIDA stands for Electronic Identification, Authentication, and Trust Services. So for trust services, you should consider long-term archival, electronic signature, timestamping, certified delivery, validation service. So these are, of course, centralized service provided by accredited subject that may add basically into different flavor. The simple trust service provider and the qualified trust service provider. And these introduce other concepts that are legally relevant. For instance, the type of electronic signature that you may use, which must comply with the process where you use it. There are basically 3 types of electronic signature: the simple electronic signature, the advanced electronic signature that is usable in a peer-to-peer commercial relation. For instance, when you buy some service or goods from any physical or juridical person, for instance. And then you have the qualified trust service provider and qualified electronic signature. And this type of signature is the maximum legal value allowed. It's equivalent to your handmade signature and may be used as truth by default in any legal law enforcement process. So why we are talking about UIDAS? Because the UIDAS has digital identity in the center. And it's moving, by the way, thanks to many European projects to decentralized technology. You may have heard about EBSI, which stands for European Blockchain Service Infrastructure. And the identity is one of the core components of the project. So, as of today, in Europe, you have several electronic identity notified schema. What is a notified schema? It's a method, technology, a set of standards that are underlying a specific protocol that is considered valid from the legal standpoint. In Italy, for instance, we have two electronic identity notified schema. The first one is the identity electronic card, which works as a standard electronic machine readable travel document, so you can access it also electronically through near-field communication protocol. You can verify the digital signature applied by the Ministry of Intern to the data that are included in the document. And the other one is called SPID. It's pronounced speed. This is a typically federated service. So you have identity provider, which issue credential to citizens and companies. And then you have service provider, which are allowing citizen and company to one-click sign up or one-click login to their services by means of this protocol. Well, this protocol is seen today as a very big innovation. But if we look at technology, it's a very old one because it makes use of a standard that is being developed for the last time in 2008, which is called SAML, Security Assertion Markup Language. It's an identity federation protocol that works mainly in web browser and is any day even more replaced by other two protocols, which are OAuth 2 and OpenAConnect, of course, which are more mobile friendly and application friendly protocol. If we look at the history, we started, of course, with centralized identity management system. Every application was creating a silos account for user. And so this brought the users to have a number of passwords that was very difficult to manage. Then we shifted to the federated identity model, which is the most spread one today. Probably you make use very often of this protocol in your day-to-day life when you log in with Twitter, Facebook, or Google to new providers. But this is a very dangerous protocol because your data are managed by a third party, which may or may not be accountable, which may or may not act with diligence in preserving your data. So this gave birth to self-sovereign identity concept. You see this acronym here, DID, DDO, MBC, and we will see more in detail later in the speech. What is self-sovereign identity? We can describe self-sovereign identity as a digital movement that recognizes an individual should own and control their identity without any intermediation by administrative authority. So SSI allows people to interact in the digital world with the same freedom and capacity for trust as they do in the offline world. Let's do an example of that. Maybe it happens that you meet with a new person which you don't know, but this person is a close friend on another person that you trust. So there is a web of trust there, and you, let's say, decide to trust the new person because of the trust relation that it's already established with this person and the other one. Or maybe you meet another person, you don't know who he is, but this person shows you an identity document which has been issued by the Ministry of Intern of that country. You verify the document and you trust that. And you trust that person because of the trust that you put in that authorities. So these are two examples of trust model. In both cases, you didn't need to go to another authority to decide if you can trust the persons. You deliberately decided to trust or not on the basis of evidence that you received directly from the person and not intermediated by another entity. To explain better this concept, let's see what happens today when, for instance, you use a federated identity model to access to a service. Now we are in the official portal of my town, which is Milan. So I could log in several ways, but I decided to log in using SPID. Okay. So when I decide to do that, I must choose which identity provider I would use. So I will use InfoCert ID because I have a credential issued by InfoCert. You see that I've been redirected to the identity provider of InfoCert. Now I'm logging in. And after logging in, InfoCert asks me if I'm willing to share my own data. I'm sorry, there is no English version of this page. To the city of Milan. So what is happening here? I'm not in control of my data. InfoCert is in control of that. I cannot modify them. I cannot decide which one of these data I'm willing to share and I'm not willing to share with the city of Milan. I might share them all or nothing. If, of course, InfoCert identity provider will be down, I couldn't access to the city of Milan portal. So now I'm in. That's exactly the concept of federated identity model. We may trust public administration, of course. We may trust qualified service provider and UIDA's regulated subject like InfoCert or other. But what happens when our data are managed by Facebook, by Google, by Twitter, by LinkedIn, and any other social network that is, of course, basing its own business model on getting information about behavior, our behavior on the net? You may imagine that. You may have saw the Social Dilemma movie on Netflix. If not, I would recommend you to do that as soon as possible. And you understand perfectly what is the problem here. So self-sovereign identity is a movement that tries to quit this model because it's dangerous for our personal life. And it's based on several set of principles. It has been introduced by Christopher Allen, which is one of the co-writers of the TLS protocol and first moving cypherpunk. And actually, at the moment, is one of the promoter of the Web of Trust conference, which is hosted at least one time in the year. Of course, not in this moment because of the COVID issue. So if we look at all these principles, highlighted in red, the principle that has to do with the decentralized registry or blockchain. We can have a look on all these principles very quickly, focusing on the main one. So existence. This is an important concept because as we all have an identity in the physical world. We have the right to have an identity which cannot be deleted, modified, or managed by a third party, also in the digital world, because our identity is ineffable. And due to this first concept, all the other are following. For instance, control or access. In any moment, I should be able to control or access to my data. And this control and access and also share of my identity with other peers must happen through transparent algorithms that allows my identity to be persistent in time. My identity must be also portable and interoperable at the maximum level with all the other ones. And this is what's happening in the physical world. We don't need to decide which protocol to use apart from the language when we meet in physical. My data must be shared with others through a consent. And the data also shall be disclosed selectively. This is called minimalization. So I can decide which data to share, or maybe I can decide to share some assertions that are based on those data. For instance, using the zero knowledge proof algorithm. And of course, this identity must be protected. So it must be based on a strong security mechanism that allows the key to be protected and used under my control. So what is one of the main concepts in this self-sovereign identity movement? It is the Decentralized Identifier, also known as DID. This is an example of DID, which is organized in three separate fragments. The Your Scheme Identifier, of course, DID. The Method Identifier, in this case is example, and the DID Method Specification Identifier. So a unique ID that identify univocally an identifier in this space. In commercial, we define the COM, DID Method Identifier, and we make it the default way to address the account of the user. So this is an example of DID document. Every DID is associated with the DID document, which has the scope which aims to publish to your peer, which are the public key through which your peer can verify that you control that DID. In this example, we see that this DID controls three different keys that are conforming to a standard: RSA, verification key, electric, and SACP. And so this will allow some sort of new way of managing key in a PKI-based system. So I'm not sure you're familiar with what is a digital certificate. A traditional X509 object. We can see it very briefly here. So let's see this type of certificate, for instance. This certificate issued to me. So these are my attributes: common name, Egidio Casati, organization, and country. This is the issuer name of the certificate national authority. And then we have the public key, of course, which is an RSA 2048 bits. you see that this strange object, which is not very mobile friendly or protocol friendly, apart from TLS and other protocol, which is difficult to parse, it's mixed in one single object, my identity attribute, name, organization, country, with one single possible key. If you look at this object, which is the DID document, you immediately notice that there are no identity attributes in it, and we can manage several keys. That's why DDO is sometimes called as a smart certificate. And if we make a comparison with the way that you usually manage digital keys in the traditional PKI framework with SSI, you see that, for instance, to manage one single key for one single use, as it must be in a good design pattern, in the traditional PKI, you need to manage 3 different certificates and 3 different private keys. While in SSI, which introduced basically a concept of distributed PKI, you just need one single JSON object to manage 3 different keys. And in this object, you can put many other, let's say, extensions like service endpoints or other attributes that enrich and unlock many different use cases. What is the role of the blockchain in SSI? Well, it is, let's say, not a core role. Of course, it's needed, but it's not at the center of the concept of SSI. Particularly, if you remember, one of the principles is that your identity must be persistent and, if possible, long life. That's the aim of the blockchain or DLT, or in general term, the registry. The registry must be the means where you record, store, and update your DID and possibly the DID document. So the function of the blockchain here is typically the resolver of DID in a DDO document. In this way, you have a way to continuously have the chance to access to the blockchain, and on the basis of a specific DID, getting the public key and be able to verify the prospect users that claims to control that DID. Of course, the DID must be described in terms of method. As of today, there are mainly 2 initiatives in standardized the sensorial identity space. One is the W3C consortium. The other one is the DIF Foundation, Decentralized Identity Foundation. But they are merging the concept together in a series of elements. And since there is no one standard, we have different blockchain, we have different key systems, we have different policies. What is required that every different initiative in the SSI space should comply to a standard document which describes the method of that initiative. This method must specify what is the scheme definition of the DID, the string generation of the DID, what and how the operation are carried out to the DID, and of course the DID document. Which security consideration and privacy consideration can be done about those methods. And of course, Commerico registered its own method. We can asset it here. And by the way, there is a list of all the methods that can be asked to the W3C consortium page, which is called DID spec registry. So if you see, there are plenty of different SSI projects here, which complies to these norms. And of course, there is also commercial network. You can find it here. Okay, yes. So we registered our own DID method. And this method specifies how the DID is created, in which form, how the DID document is specified. If you see, the DID document contains a proof. And, sorry, it is in this way a secure object, which cannot be modified. It can include end service endpoint and other ways to use the object. And also, we describe what are the DID operations we can do with the DID. For instance, regarding DID resolution, how a user that receives a signed challenge, for instance, by another user claiming to control a DID, may verify this condition. So if you look to the official commercial network documentation, you see that the full node of commercial provide a REST interface, and particularly this REST API, that on the base of the DID returns the DID document. So you can get all the information of the public key, so the verification keys that you can use to verify that these users effectively control the DID. But there's another important concept here that allow another type of use case. We can define a public DID as one single object, one single identifier that is publicly related to an entity. By entity, you can think about a physical or juridical person, for instance. But since we are using a blockchain, all the transactions that will be performed by that entity will be in some way related and correlated by a third party that listens to the blockchain. So there is a chance to improve the privacy of that entity by using specific DID to talk with specific peers. And this method is called pairwise DID. What is a pairwise DID? You can imagine as your telephone agenda, where every of your peer negotiated a different DID with you. So you will have a different DID for any of your peers, and your peers will do the same with all the other content. In this way, a third party that may try to search the blockchain transaction, the internet connection, whatever, will not be able to correlate different action performed by the same entity, because that entity is using different identities, and particularly decentralized identifier. Of course, this use case is unlocked by a technology which is the hierarchical deterministic wallet. So if you build your identity wallet using that method, by the derivation path, you can have an infinite number of key pairs and DID. Another important concept of SSI, of course, is your identity data. You remember that when I used speed to access the City of Milan official portal, my data were shared not by me, but by the identity provider of InfoCert. So this is a big problem. I trust InfoCert, of course, but I don't trust any other internet provider. I will be happy to share my data directly from my wallet to the service that I'm logging in. And this can be done through the use of another type of object, which is called verifiable credential. Verifiable credential, it's another new standards of the SSI framework that is dedicated to, let's say, describe your identity attribute, your property, your connection to other, whatever can describe your identity to others. Basically, is a set of claims and claim metadata that are signed to be proved authentic. It can be signed by yourself. In that case, you are self-issuing a verifiable credential, or they can be signed by another party, which may be or may not be trusted by your peers. This party may be an official, accountable, liable third party, which issue credential to users. For instance, a digital certificate issued by a certification authority, it's a prototype of a verifiable credential because it's in your hand. You host those data, you control those data, and you share those data when you sign a document. But you cannot decide which one you must share. You must share all the data in once. So you don't have minimalization. And you have a single object for managing keys and identities, which is not a good pattern. Here, the DID, the DID document, and the verifiable credential are separated objects that can be used with maximum flexibility. The verifiable credential, DID, and the document, of course, are at the base of the standard trust model to the self-sovereign identity movement. So you can see here the holder, which is the center, and actually is an entity, physical, juridical, or whatever, that have its own decentralized identifiers stored in identifier registry, which is accessed and accessible by all the other parties. Then you have an issuer. This issuer typically issue credential. The holder, of course, can issue credential to itself, but from the business point of view, that should not be a big deal because, to make business, you have to provide trust. And so a third party which is accountable that states something about yourself creates an identity attribute which is more trustable to your peers. So the issuer typically issue credentials that are stored in the holder wallet, and then the holders present this set of objects, which is the authentication through the DID authentication process, and credential to a protocol that is called credential presentation, which allows the holder to mix the identity data in his wallet in a form that is the best one to preserve its privacy to the verifier. All these subjects may access to the registry to resolve the DID to the DID document and being able to authenticate the holder anytime it's needed. The verifiable credential gave birth in the first decade of 2000. And here there is a paper, which is one of the first papers to talk about claims, identity claims separated from keys. And it's a good work because it's let us understand which are the categories in which this credential may be inserted. So for instance, we have static identifier of your identity. These are very dangerous attributes because once you have shared with the world, your attack surface layer is widening. For instance, your social security number, your telephone number, your email are typically static data that you share with others, particularly the date of birth or national identifiers are data that doesn't change for your whole life. So it's very dangerous to share this data with others. Then you have claims about your relationships. For instance, being part of a specific group or a specific category, or acting as parents of a trustee of another subject. Then there's an interesting category is the derived claims. And this use case is very interesting, for instance, to show that you are complying with the requirements without showing the data that demonstrate that you are complying. For instance, you have to be an adult, and nowadays, if you show the document, you must show your date of birth. But think of it about as in this way. You are showing a cryptographic verifiable data stating that your age is about 21 without showing your date of birth, thanks to zero knowledge algorithm. Then there is other typically minor claims, type of claims, which are capability and contextual. So capability, for instance, it's to demonstrate that you can do some types of operation, for instance, accessing to the root folder of a website in a specific domain, to demonstrate that you control that domain. And contextual, of course, are based on time, location, and authentication technology. This is an interesting concept because particularly for authentication technology, if you remember, one of the principles is protection. If you look at the standard and traditional market for, let's say, digital signature tools, and particularly when we are talking about electronic qualified signature, you will understand there are some standards issued by European Technology and Standard Institute, ETSI, that are related to the certification in terms of security of the means that you use to sign a document. I'm talking about smart cards, HSM, High Security Module, that must comply with some specific framework for certification. For instance, common criteria. In this case, you are talking about secure signature creation devices. But nowadays, in the blockchain panorama, there is nothing like that. Very little or no project at all at full node level use a certified HSM. And on the client side, everything is left to the user. Of course, this is a good thing for technology-wise user, but it's an awful thing for standard user because they have no clue of what they're doing, and their security may be very, very low. I was talking before about minimalization, and verifiable credential presentation is the main protocol to produce a proof of your identity data without disclosing them, or also deriving them in predicates. and assertion that are cryptographically based on your original data. And of course, when we talk about the decentralized PKI protocol, like SSI, there is a way to authenticate the user on the basis of its DID. Typically, it's a challenge response protocol. Imagine a user that wants to log in to a service, of course, using its own DID and set of keys. This allows a passwordless authentication scenario, of course, because the web page may provide a signed challenge to the user. The user can use directly its browser or its smartphone with the identity wallet, taking this challenge, signing it with its private keys, and produce a response that includes the public data. Public data are, of course, the DID. So the web server may access to the registry on the basis of DID, and on the basis of the DID method, resolve the DID in a set of public key, and finally verify the signature produced by the client. This is a kind of TLS protocol at application level. Well, in the United States, if you remember, everything started with PGP and the Web of Trust. And thanks to the blockchain, initially Bitcoin, of course, this concept has been renewed. But in Europe, we have a very advanced regulation, and we have a culture at enterprise level that allows users by any country to exchange data with in other country in a cross-border architecture to be fully compliant to regulation. That's why it's very difficult to, let's say, get rid of a trusted third party. But this doesn't compromise in any way the self-sovereign identity model, because the important thing is that the user is in complete control of its data. It's not important that those data has been signed by a third party. Probably it's better. But the important thing is that that third party is not involved in any other process and is in any way capable of interfering with the use of those data by the owner. So we can imagine to use the self-sovereign identity at enterprise and public administration level, mixing the tools that we already have with this new technology. For instance, I don't know if you're familiar with a concept which is called European Trust Service List. Nowadays, there is a directory that includes all the subjects that has been accredited as a qualified trust service provider. For instance, you see here, okay? And when you access to this data, you see all the keys that are relevant to verify signed data by the users. So if one of these subjects is issuing verifiable credential and it's signing this information with these keys, you can apply the same trust model. In the same way, if a third party that has been acknowledged by these subjects is issuing credential, you can apply the same principle. And so you have a trust model. And that's what we introduce in commercial. Commercial network trust model, we define a hierarchy that starts from the government, which is allowed to define trust service provider. And this trust service provider can issue identities, but particularly verifiable credentials to companies. And the blockchain, mainly it's used as a DID resolution mechanism. In this way, two companies may exchange data, trusting each other on the basis of what have been stated and issued in terms of verifiable credential by a trust service provider. But remember, the blockchain commercial network is a true blockchain, so all the transactions are there, available to the party involved, but also to third party. So we have to avoid to allow a correlation use case by third party that are watching the transaction. That's why we introduced the pairwise DID mechanism to commercial network. So consider, for instance, two different TSP that are issuing verifiable credentials through two companies or two subjects. We call them Alice and Bob, of course. Alice and Bob off-chain may negotiate the exchange of two different new DID, which are Alice pairwise DID and Bob pairwise DID, using their own public verifiable DID and verifiable credential. So I can use my public DID and my verifiable credential data to demonstrate to Bob, as Alice, that I am Alice, and Bob can do itself the same way. And when they do it, they have a secure channel through which they may exchange a pairwise DID. And from that moment on, they can use pairwise DID to perform off-chain communication or on-chain communication. For instance, in the case of electronic delivery that must be provable to a third party anytime after the transaction. If we look at commercial network documentation of the SDK, you can see in the identity modules all the stuff that I have been trying to explain you. So you will be able to create an identity, enriching your account, which is already proposed in the form of a DID, with keys. And how is do that? We have a plenty of SDK you can use to do that. For instance, we have different language, and typically we have two SDK. Sacco SDK is in charge of taking the message, signing it, and sharing with the network. While commercial SDK is the business SDK. So at this level, all the modules, all the interface of the modules are implemented and available. If you look at the repo here, and we go to the lib, you will see that you have ID and crypto. Let's look at crypto, for instance. There is an helper for keys that allows you to create key pairs of any type, RSA, elliptic curve, etc. So these are keys that will be inserted in the DID document. If we look at the ID module, you can see that you have DID document helper, or let's look at ID helper. So you will see how to create a DID. And this will make use of the crypto helper as well. One last important concept that I want to show you is the concept of PowerUp. We will go back to the pairwise DID mechanism. Consider the case that Alice and Bob are negotiating two pairwise DID. And then they want to use this pairwise DID not only to communicate off-chain, which is for free, but also to do transaction on the blockchain. In this case, you have to do you have to prepare a fee to perform a transaction. So you have to get in your wallet commercial token or commercial cash credit. But this token may not be exchanged, might be sent from the public DID to the pairwise one, because in that way you will get a correlation of data. So we created a central component, which is a tumbler that allows any account to send money to a pairwise one without letting a third party know that there is a relation with this component and this one. So this was the last concept that I wanted to talk to you about. Now I'll leave the word to my colleagues, Enrico, and that will show you together with another colleague, which is called Enrico Pasquali, how you can use the SDK to create your identity on commercial network. So until next time, thanks.
Okay. Well, first of all, thank you very much to Egidio. Amazing presentation, very clear. I think it's probably Egidio is, by the way, the father of speed. So the person that a few years ago, like let's say 6, 7 years ago, he kind of like conceptualized the concept of speed, and he's and Italy, the nation of Italy, implemented this vision of speed. So I mean, we're like humbled to have him here at Commercial Network on board. He's one of our advisor, and he's like the architecture, as he's explained, of the whole commercial, let's say, infrastructure and idea. I just want to show you just a little bit before I speak with, I pass the floor to Enrico. I just want to basically, let me just like share my my Safari. Basically, you know, let me talk a little bit about commercial, just only to understand where and how to find things. So, you know, in a nutshell, basically, commercial network is we call ourselves the digital transformation blockchain. Why? Because, you know, digital transformation is this big catch-all phrase that encompasses all this trend of companies going digital. And in order for companies and people and nations to go digital, you need to have the fundamental pillars to go digital. And, you know, the 3 pillars of the digital transformation, there are 3, and are like, you know, the identity, which is, you know, what it's all about and what we talk about today. Then we have like the signature that, you know, provides the validity of a document and anything. And there's also the certified delivery, saying that I send you something, and, you know, I can prove that, you know, that was the document, was the time that I sent this document. So it's kind of like, you know, like a time-stamping integrity thing that that proves that I, as, you know, my identity, the owner of the keys, the owner of that identity, myself, have signed. So I prove the validity of the fact that I subscribe, say, yes, I agree to this document. And then not only that, but also I send it to you, and I can prove it that I sent it to you today. And that was the document I sent you, was not something else. So in our blockchain, we do that. So we kind of like got all that ADAS things and we put them in a single, organic, coherent place, which is the commercial network blockchain. So these three things, the three pillars, are the one that basically are enablers, and allows anyone to create applications, solution, websites, anything you guys want to do as hackers, to use these three pillars, the three instruments. Most amazing stuff, it's that everything has it's ADAS compliant. So basically in Europe, it means that everything you do on the commercial has a legal validity. Means that it's kind of like whenever I sign something, I can be accountable. And it changes a lot, because whenever you do a simple signature, whatever, simple electronic signature, yeah, of course it can be valid, but I need to go extra length to prove it. And in a way, ADAS give us the laws, they give us the directives to basically be compliant, be legally enforceable throughout Europe. Okay, and not Europe, because also there are other countries the Singapore and Australia and other countries that basically employ the same principle. So it's not only Europe. Of course, Europe, the digital transformation business in Europe, it's huge. We're talking about 2.2 trillion euros in the next 10 years. I mean, it's mind-boggling to think about this huge market. Why? Because basically every single customer, every single company, every single government, every single university, every single school are trying to move from paper-based identities to paper-based signature, paper-based delivery methods, to basically online and digital. So that's all the digital transformation. So companies will absolutely start and embracing, especially with COVID-19, which just gave a super speed up and super power up of the digital transformation. Why? Because we don't longer have the luxury to meeting with each other. So sometimes we need to sign let's say a deal, a project, a contract, and we cannot be together and use the piece of paper. And we still need to sell our car, we need to sell our house, we need to have many things we need to do. We cannot do it right now in person. So now it's the perfect time to start and using the digital transformation. So commercial network is an open source, 100% open source. Everything is open source, and we use what? Of course, the best available SDK for creating a blockchain, and which is of course Cosmos for us. The day I met the Cosmos people at the DevCon was a life-changing moment for us, for our project, because we shaved 2.5 years of time. And I think that Cosmos SDK has provided to be the most amazing space, the most amazing tool for creating our vision. Okay. Now, having said that, let's start a little bit to go into the detail of what is, what we can do. As I said, Egidio explained you the principles, the concept of a sovereign identity, the way that can change and transforms the way we share our personal data and we use it, and the way that we can become in control. We get we are the center of the exchange. Of course, it's our data. Why should be why our data should be owned basically by a corporation? Should not. So we should own our personal data. So that's the biggest important factor that it is. So sovereign identity means that I own the data and I decide who should have my data on a granular form, not, you know, all or nothing. I hated the idea of leaking everything about me. No, you need to have my email. I'll give it you. That's it. You don't need my date of birth. You just need to have to understand that I'm over 18. Yes, I am over 18, but I don't want to tell you which decades I come from. I'm from the 70s, okay, and I don't want to tell you because I can be discriminated in like looking for a job. So I will tell you exactly that I am only over 18, so I can apply for this job regardless. So there's no discrimination. There's a lot of things that we can do with this self-sovereign identity. There are a lot of things that it can be done when we get back in control of our data, personal and also organizational data. So, you know, things like about our company and about ourselves. These are the two things. So in the last, we started commercial in 2018, and we raised a little bit of money to get to this open source software. So we transform all the seed money into open source software. And, you know, we build a lot of software and everything. If you go to Commercial Network, you go to tools. Okay, this is the page of everything we've done, and we have a lot of open source software. Okay, the first one, it's the core layer. We have like 4 layers. Okay, the core layer is basically the blockchain node. So this is basically Cosmos plus. Okay, plus of course all the modules that have described. And we have like the document modules and membership. The most important, for the sake of this is like basically the identity module. So anyone that wants to implement a self-sovereign identity should not start from the start, should not be like start from the beginning, but should really take a look at what we've done, because we did the DID. Okay, we basically created here the whole basic module that implements the self-sovereign identity. So anyone wants to play around, please do not start from scratch. Just fork this part of our repo, and you know, and basically start from there. Don't start from scratch. Okay, then that's the basic layer. So we have like all the things that should be done, should be on the blockchain, which is no personal data ever. Okay, so the persistence of the data of the, let's say resolver of this data, it's on the blockchain. Then we have another layer, which is the cryptographic layer, which is very, 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 very important, because this is like not for commercial, but this is for any Cosmos SDK. These are very, very, very important tools. Why? Because we keep them updated. We spend a lot of time to update them, and this works for all Cosmos SDK. So you can basically use it for your own project. Every single project in the Cosmos SDK space can use this SACO cryptographic layer. It's like, this is like was like our first open source. We started with Dart, then we go like Java, Kotlin, then we go like C#, and then we also have Golang, because, you know, since this is like the core layer is done in Golang, it was like pretty easy to create also the SACO Golang. So this is the cryptographic layer. Now, on top of it, we have also the application development layer. So basically, you have like all the business logic stays here, because we want to keep these two separate. We don't want to have like a cryptographic layer that has like something to do with commercial. Would be wrong. We want to have it like separated, so anybody can use this and use it for their own sake, and everybody who wants to use commercial for identity or for anything else can like use it and fork it and do whatever they want. It's very, 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 very simple, basically way to do it. Now, of course, we're talking about like SDK node. And now we need to start thinking about the user, how the user will interact with us. Okay, So we created the fourth layer, and with that we completed the full stack. Okay, I think that probably we are like one of the few projects that actually achieved the full stack within the Cosmos ecosystem. So we basically created all the four layers in which the user interacts, and then like the developer creates the business logic, and then like uses the cryptographic layer to sign and send the transaction to the node and the node itself. So in here you have like the full stack, and everything we did, it's completely 100% open source. So anybody can go and take a look and do whatever you want to do with our code. That's it. Of course, we love PR, so everybody who's listening to our to this speech that wants to help us, maybe somebody is good with Dart or Kotlin or C# or Go, can help us do and help us and join our open source community. Okay, so let's say that the Sacco is very, very cross-platform, projects, and this one are a little bit more specific to commercial, but nevertheless, we have a Vue.js also Explorer, which is specific to commercial, but can be used and can be generalized with every other project. Okay. And then the two pieces that I will just briefly explain, because today we're gonna have basically the creator, the father of these two pieces of code, which is basically my good colleague called Enrico as well. Great name, by the way. And this is like commercial UI, which is like a pre-built clean core widgets library, and it will explain to you very well. And then there is the probably one of the coolest thing that we produce, which is the Amedeo app, which is basically, it's a boilerplate, it's a starter app that will make you create a project in few minutes, and that's it. So with that, I'll stop sharing the screen and I'll stop talking, because I will pass the word and pass the floor to Enrico, and he will explain basically commercial UI, Flutter, and everything. So thank you, Enrico. You can go.
Thank you, Enrico. Great presentation, and also by Egidio, of course. Very, very well done. Okay, so we have seen with Enrico that, let me share the screen. Okay. Okay, better. So for the topmost layer, we have chosen to use Flutter. What is Flutter? Well, it's a cross-platform framework made by Google. Okay, and is relatively new, and we are using it a lot. Is very, very fast development time. You can create a cross-mobile application on Android and iOS, of course, but also in their development channel, you can build a desktop application or web application. Yes, those desktop and web applications are experimental, but almost stable for now. Okay. So the Commerico SDK is built in Dart. There are three versions: Dart, in Kotlin, and C#. Dart is a language whatever Flutter is a framework. Flutter is written Dart, but is a UI toolkit. So with the Commerico SDK, you can write both client and server applications, because it doesn't have any UI related widgets or components. So to develop application to the final users, we have developed the Commerico UI and okay, let's see, and Amadeo. Okay, Amadeo is a boilerplate app that contains all the Commerico network available modules. Whatever, okay, and the Commerico UI is the core library that can speed up the development time by a great margin. You can be productive very fast with it. So let's just see the code. Okay. We have here Amadeo. Amadeo is using the Commerico UI library here, directly from GitHub. And it uses the uppermost layer of Commerico UI. That's because Commerico UI is built on layers also too, like the Commerico network libraries. So it starts at the bottom with a stateless layer. This is a wrapper that wraps the Commerico SDK Dart library. Is made to also has more functions to work with keys and the okay. Let's see just okay. This is the Commerico account module. So we can see that it exposes several methods. For example, to generate mnemonics with the Commerico SDK, you need to import a BFI 39 compatible mnemonic word generator. With Commerico UI, you have it inside the library. Also, we have done all the lengthy work on manage keys and secrets. For example, the mnemonic keys that will be attached to a wallet. These keys must be kept private. So in Flutter, there are different libraries to do that. We use a library that enable you to interact with the storage, secret storage of the device. On Android, we have the key store. In iOS, we have the keychain. So the credentials and also the private keys used to sign a DID, a DID document are kept private. Okay. So let's see just some code of Commerico UI and later how to use it on Amadeo. Okay. We have the stateless and stateful layers. Stateless are the most basic APIs. They translate almost exactly to Commerico SDK. We will use the Commerico stateful. Commerico stateful layer is a layer on top of stateless And this enable the developer to forget about remember to store the state of the keys, the network informations, the storage type keys, and it is also everything inside this layer. Okay. For example, we can see here a method to generate a new wallet used on the blockchain. It requires two optional parameters, mnemonic and derivation path segments. Okay. Mnemonic is a sequence of 24 words that are used to determinately generate a wallet, and they are optional because this layer can automatically generate these mnemonics and save them to the secure storage for you. But if you want the user to provide his own key words, you can do that. And the last derivation path segment is used to generate a pairwise wallet. Okay, we'll see that. And we can see that automatically the stateful layer can save and retrieve private information from the secure storage of the device. Okay, let's see here. Commerico UI, and okay. So why this library can improve development time? Okay, if we use directly the Commerico SDK, like I said before, we have to write a lot of code. For example, the generation of mnemonics, secure storage, but also, for example, the wallet is an expensive operation to do in a mobile device. So in Dart is useful to do that in a separate isolate that is like a thread, and this requires the developer to write some Dart threading code to calculate the wallet in a separate thread, and not the UI thread that it must render the UI to the user, of course. Okay, this is the Commerico UI version. It's smaller, and it uses block on the uppermost layers. We provide the functionality onto the tree, the widget tree, and the library on the UI layer provides a lot of widgets pre-built. For example, we have a generate wallet button and the text field. Those widgets already uses the blocks inside to send events. So the flat button send a Commerico account generate wallet event here. Automatically, the button will be disabled while the operation is going, and the generate wallet text field will display the loading text while loading, and the wallet address derived when it's done. This is automatically done by the Commerico UI library. So the developer doesn't need to implement some custom logic, work with storage, state management. Is already all done on the block UI layer of the Commerico UI library. Okay. We have seen the stateless layer. Okay. So let's start from the main of Amadeo. Here, our required object is the stateful Commerico account. Commerico account, we have here, okay, is one of the models of Commerico, and it keeps the wallet of the user. We can see in the documentation of the SDK how to generate it. We don't need to deal with that because we can provide our network informations. In this case, we provide the Commerico development blockchain address and URLs, for example. Okay. Here we have the helper to access our Commerico network blockchain in a very easy way, but you can provide your own addresses. And okay, so after we have created this object, this is one of the most lengthy parts, but you can find it on GitHub without problem. And for block developers is also all normal without problem, because we are injecting our repositories under the application. So we create our repositories. Those are the Commerico UI custom repository. We here enable all the modules. So Commerico account, Commerico docs, ID, Mint, KFC. Okay. So now that you have injected on the widget tree or providers, we can use them here. We have a set of pages. So let's build the app. Okay. For example, in this page, we want generate the user wallet. To do that, we can use the block builder and use the Commerico UI given generate wallet block and generate wallet state. Okay, if we would see, okay. Those blocks are pretty simple. They only use the stateful layer. So this is an important point. The Commerico UI uses block on the uppermost layers, but it's not required because you can just use the stateful or stateless layers with any state management solution. For example, the already built-in change notify or value notify. We have some examples on the documentation. Let's see if I can find it. Okay. So I write some examples, for example, with change notifier. we can use the stateful commercial account module and notify the listeners that we are generating the wallet and use it directly in the code with the provider approach and package. For example, MobX is another popular state management library. It works the same way. We can use our stateful commercial account module in it, write down the observables, actions, and observe the change of the stores. Also, GetX, popular state management library. Very simple. Put in the registry the service, the stateful commercial account, and write the controller here to encapsulate define the service using get, updating the generating Boolean flag. Using the service to generate the wallet is already all done on the commercial UI side. So we don't need to do, for example, all this code with also storage, with also thread management. This is all done in the commercial UI with simple API. Okay, and in case of GetX, we can use it in the widget tree and render the wallet resulted wallet. Okay. So back to Nadal. The code is very simple. Also, we here provide a custom implementation because we can listen to our blocks. So you don't have to use the widgets provided directly, for example, generate wallet flat button, but you can write your own implementation. Here, we listen to the states that the block emits, because for every event, the blocks is just a controller in a model view controller architecture. We can list at the state, and when the wallet is generated, we just update the text field with the generated mnemonics. And while loading, we display the loading text. On error, we don't have nothing. Okay. Here we have the text field. And here we use the generated wallet text field that is built in commercial UI. This is a part of the widget UI layer. We have text field that listen to the states generated by the block, and directly we pass two callbacks required: the loading, that display the loading text, if any, and the text, that is what display when the block emits a successful state. Like any other text field, we can provide all the custom styling or layout, everything, color, because they are built on the already Flutter widget, already existing Flutter widgets, that is text field and form text field. So we have all the Flutter styling options. So you don't lose any styling option to display how you want your text field or where you want it. Is maximum flexibility. So let's see. Here we have the modules that we have seen here. Okay, Commerico account, ID, docs, sign, and mine, KFC. So Commerico account, we have a list of subsections. Here we are in this page, the generate new wallet page. This is the generate wallet flat button, and this is from Commerico UI also, already communicating with the block. So we don't need to provide a loading state to and rebuild the tree. We don't need to take care of error messages. There is already error function defined, but we can provide, of course, our own widgets and logic. So if I press generate wallet, let's wait a moment. Okay. Here we have our 24 mnemonic words that must be stored securely. And this is the generated wallet DID of Commerico, of course, Commerico method. And this is the Cosmos related string. So now the Commerico UI library with the default options already generated also the wallet and the mnemonic keys and store them on the secure storage. And this was done only with two widgets. That's very, very fast. You just put the flat button and the text field, and you have done the generation and receiving state part. All the rebuild, listening, disposing of the widgets are already taken care by Commerico UI and the block library. So, for example, we can restore the mnemonic words. And this is the wallet restored. If we go to the page, okay, we have the restore wallet text field, that is this one. And okay. And okay, a flat button to send the event, the block. This event is a Commerico account restore wallet. Here we can use the restored. Oh, sorry. Okay, sorry. I took the wrong page. Okay, here we have a very small widget. If you have worked with Flutter, you see a lot of stateful and big widgets with a lot of state to take care of and rebuilding parts. Yes, you must split the tree in multiple parts, and you should do that. But with Commerico UI, you just okay, we create the basic layout with padding, the columns, 1, 2, the text, but with only the flat button already built in Commerico UI and the text field receiving the event is it's already done. There is nothing else to do, and we have our working page or widget, and in this way you can build an app in a very little time. For example, we go through all the commercial options. For example, generate a QR code from the wallet. So this QR code refers to your wallet address. Also here, we said earlier by Egidio that is a faucet on the blockchain. So our generated wallet are stored only on the device for now, also our mnemonic case. If you want to add the wallet to the blockchain, we need to request a faucet invite. Only this option is only available in a DevNet. So, for example, we can use the Commerico Explorer, also from here, Commercial Network. There is the Commerico project. This is a development network. So here we can require an invite from the faucet. So just send the request. Okay. And Commerico shows how the transaction. This is the, okay. This is the transaction hash. And we have been invited from the faucet, and now we are registered on the blockchain. So we can now send and receive some transaction on the chain. For example, we can ask the faucet, also only available in a development network, not in a real network with the real money. We can request some tokens from the faucet to start with the our tools to explore the APIs. You can use Commerico to explore the transaction, for example, and build Amedeo to test commercial network related operations, test the SDK or the commercial UI libraries, and you directly from Amadeo send a transaction in a DevNet for free. Basically, you can test whatever you want. Okay, we can try to send tokens to another address. Also, all these operations are on the account module. So these sections have APIs on stateful or stateless commercial account. We can see here the wallet generation and the request of free tokens from the faucet or the account balance. Okay. So with just two widgets, we can use the block that uses this innermost layer. Okay. And we receive a standard coin entity. There are some entities defined in Sacco library and the Commercio SDK libraries. That's because Commerico UI under the hood uses Commerico SDK and Sacco. In fact, every message to the chain must be in a specific format. Okay, here we have an example. And to build the transaction and sign them, we use the Sacco and Commerico SDK modules that already do a great job on that. No need to reinvent the wheel. So in your uppermost layer, for example, in Amadeo, you will receive the SDK, the standard coins. Okay. Here we do just some work to display in a human readable format. For example, converting the object to a string. But the code is almost here. We have the standard coin, the translation, but it's already all the logic is in Commerico UI. You don't need to worry about how to compose the messages, how to create the JSON, how to encrypt the fields. It's already did in the other libraries. You just build great apps. So we can send now some tokens because we have a wallet and we have sent it to the chain. So here we send some tokens to a predefined address that is the faucet. We send 100 tokens of Commerico. We can send another type of tokens, for example, Cosmos tokens. It depends of the chain connected to your application. You can choose here on the Stateful Commerico account. You can choose the type of the DID that you are using, the tokens, and so on. Okay, so we have sent tokens successfully. We should see transaction. Okay, we have sent our tokens, and you can see this operation is completely simple. There are this is a stateful widget, okay, only to store the text controllers, but there are no loading, state management, anything of that. Okay, we have seen the account, so we can jump to ID. Here, okay. The identity is another layer on the Commerico UI. And we can manage with this layer the private and public keys. So if we go to ID, create, for example, here we can create a DID document. To set a DID document, you need to generate RSA keys. This is an expensive operation, but the Commerico UI library already do that in a separate layer. You don't have to use an isolate, separate the code, generate the custom functions and parameters for that. It's already done in the Commerico UI library. So we can see that we have the generating word. The button is gray because the loading event was sent to the block, for example, here. The expensive operation, so it's done in a separate thread. You can see that. Okay, here we have just the JSON encoding of the generated keys. There are 4 keys, 2 key pairs, so signature and verification RSA keys, public and private. Okay, we need those keys to set a DDO. Okay. So if you want to create an identity in the chain, you can do that only by using those widgets. For example, to do all of these, we only used generate keys, fat button, and text field. All the logic threading is all done in the Commerico UI. Okay, now we will use this code. Also uses the Commerico UI topmost layer, the flat button to derive a D document, and the text field to display, for example, is not required, the result. This is exactly an identity that you can attach to your profile, to your, yes, to your identity. And this set document will send the transaction through the chain. So in Commerico, okay, this is the transaction. Those are the keys generated by Commerico UI, and they are automatically stored on the device secure storage. So for example, we can generate them, restore them, delete them. So it's all handled by the Commerico UI library. To derive a DID document, the DID document is already is very simple. We try to keep the optional parameters wherever we can. So the fee to the transaction is optional. A standard fee is calculated if not provided. So broadcasting mode is optional because we wanted to provide the fastest experience we can possibly make. And this is the last part of the ID. So to request a PowerUp, we can we must for now send tokens to the Tumblr. This part is required to enable the Tumblr to work on our request. So we can change, for example, the amount. And this is the JSON. You can write your own implementation of that on top of the Commerico SDK, but it's not required, as I say. Is everything already done? For example, recharge the Tumblr is you only need to specify the amount. Is pretty simple. the PowerUp request also, you only specify the pairways address that we see now, and this is the PowerUp request. No need to RSA encrypt the objects, anything of that. You just use the pre-built widgets or write or your own implementation of that, and it's done. We have okay. We see. Okay, 4, 7. Okay, okay. I sent it 2 times. Okay, this one. So we did all the JSON configuration in no time. It's everything already pre-built. So here we can use another pairways address. You should use a pairways wallet, one for each of your contacts. How can you generate the pairways wallet? Well, you can see in Amadeo that there is a slider. You can see here a derivation path. Initially, your wallet is generated with 0 or 1, and by specifying a custom number, you can generate a wallet for every contact that you need, and this is deterministic, so you will see the same wallet every time. So from the same 24 mnemonic words, you get your wallet, and by specifying the latest number here, you can generate deterministically the pairways wallets. How I did this in code? Well, it's simple. We can use the generate new wallet function that we see before, and it takes an optional argument, the last derivation path segment. Here is the 6. So if you don't provide any argument or only the mnemonic, your personal wallet will be generated. If you provide a string, for example, 6, the system will derive deterministically the 6th wallet that belongs to your connection with a selected account, for example. So no need to separate APIs. You can use only one function, and you can generate wallets with this, and also the pairways addresses. So if we see here, you can see the base path. Okay, we updated the slider. Okay, with simple 2 widgets, flat button and text field is the Commerico UI magic. You can generate your wallet, pairways wallets without issues. And there is a lot to discuss, but we don't have a lot of time. You can see through GitHub all the code and the implementation of Commerico UI. So here we have the 4 layers. For example, if you want to see how the widgets are made, sorry, or the blocks. Okay. They are pretty big because of Dart limitations for now, but you can only wrap with block and any custom widget. You just intercept the emitted states and provide the required events, and you can customize every widgets you need in your interface. Okay. You can see the repositories. Last but not least, we can see, for example, in the section, we must provide the service and the block we need. This is because we can separate with the same block. For example, we can use the same block in different parts of the tree. And we can do that without override the same object, providing only on the subtree part what we need in that specific code. So for example, here we need only to generate a wallet. So we only provide the specific functionality that we need. And under that, we can use the UI widgets that we seen before. Okay. So we have seen the account ID modules. I try to explain some of the inner workings, but with all the layers, it's very simple. There is no need to provide your own custom implementation. You can start directly with the provided widgets, build your app with that, desktop, mobile, or wherever you want, because there is everything that you want or need out of the box. So I think it can be a great start. And if you have suggestions, you can also send a PR request or fill up some issues, and we listen to you. So no need to go through all the SDK documentation, only the UI widgets. Yeah, I think.
Perfect. Absolutely. Thank you very much. I think amazing job explaining all this. Thank you very much, Enrico.
There's a lot of code. I try to.
Yeah, a lot of code in a very few time was amazing job. So, okay, so in this Sunday afternoon, thank you very much again for sharing all this information. And basically, that's the end of our workshop. I hope that has been like a very clear, or at least gave a glimpse of sovereign identity, about Cosmos SDK, how to write Cosmos SDK module, how to basically use the SACO cryptographic layer to send and sign transaction, how to use the SDK to basically build the commercial UI, and ultimately how to build a front end user application and put them in the hand of the user, which is basically the end idea of what we've done, because we wrote a lot of software, but we want to kind of change the way that people share their personal data. So that was like our project from the beginning, and I hope that a lot of people will use our software without rewriting from scratch. And Amadeo is the boilerplate app, and everybody can use it. It's there. You can build an authentication app, an identity app, a delivery app, signature app, token app, KYC app, any kind of app that will be solve your user problem. So thank you to Egidio, thank you to Enrico, and thank you to all the listeners that have stayed together with us for 2 hours. Okay, on this Sunday. Thank you very much, and good luck for all the hackers in the hackathon. And we hope that we shed some light into the sovereign identity. Thank you very much. I'll give back the floor to Dogimos so he can either do whatever he wants. Thank you. Ciao, Enrico.
Thank you. Thank you.